So I've just shown you how to use the HANA Instruments kit, and you've seen that they provide you with an indicator which changes from blue to yellow. If you use the AquaMerc kit, they use, I think it's a methyl orange or methyl red based indicator which changes from greeny blue to red. So you just have to be aware of which indicator you're using. And just for completeness, I'm going to show you yet another different type of indicator. This one comes in a little sachet, it's a powder, and you can see it says BCG-MR, and that's a mixture of bromocresol green and methyl red, and that has a sort of green to red colour change at pH 4.3 or thereabouts. So again, we tear open the sachet, got our water sample here, and we simply add a bit of the powder. Not too much, because there's quite a lot in there actually. Give it a little shake. And this particular indicator turns green when it's above pH 4.3, not blue. But the procedure is just the same. We take our syringe with acid, we add the indicator drop by drop, and you can see that it starts to turn red. Sometimes you need to give it a good bit of a shake, because the colour change can go quite slowly. You think it's gone, then it goes back to blue again, or green. But this time I think it's really gone. And surprise, surprise, actually the result is exactly the same as when we used the bromophenol blue. It's 0.21 millilitres of acid we added. So we've done the titration 3 times today. We've got results of 0.2, 0.21 and 0.21 millilitres of acid that we've had to add to 5 millilitres of solution. Now here's where you need to go back and read the instructions. If you use the AquaMerc kit, we're not using that, but if you use the AquaMerc kit, it's simple, because the acid syringe is already calibrated in terms of milliequivalents of alkalinity in the solution. So if you'd done the titration with the AquaMerc kit, you'd have been able to read off from the syringe directly how many milliequivalents of bicarbonate there are in the solution. HANA don't make it quite as simple for you. They simply allow you to read off the acid amount in millilitres. So the average of those 3 determinations is 0.21 millilitres. And then you look in the instructions and they say that you multiply that figure by 300, which, if my maths is reasonably okay, is 63. And that's the number of milligrams, trying to write upside down here, per litre of calcium carbonate equivalent there are in the water. I don't like this way of citing alkalinity, because alkalinity and bicarbonate doesn't necessarily come from calcium carbonate, so I just find this confusing. But in fact, it turns out that 1 milliequivalent of alkalinity is equal to 50 milligrams of calcium carbonate. That means that we simply divide 63 by 50 and we get 1.26 milliequivalents per litre of alkalinity. And because this isn't very accurate, I probably would simply say 1.3 milliequivalents per litre. So that's our result for how much bicarbonate there is in the solution: 1.3 milliequivalents per litre of alkalinity. That's quite a small amount of alkalinity. So what you can actually do, if you want a slightly more accurate answer, you can take not 5 milligrams, you can take 1, 2, 3 syringefuls of water. That's 15 millilitres in total. Do the titration again and you should use 3 times as much acid. And then instead of multiplying by 300, you simply multiply by 100. That should give you much more sensitivity in the determination. It'll give you the same result, but just a bit more accuracy. I hope that's been reasonably self-explanatory. Do give me some feedback on this video if there's things we could have done better, and I'll try and remake it. Finally, thank you to my daughter, Jenny, for doing the filming on this. Let's go inside, have a cup of coffee, and see how wobbly the filming is, shall we?